watching the news. I was just reading, I had to pull myself away to finish the right to make these slides. Right. What's the news? Hi everyone. We're opening the last day of the workshop. Today's going to be a lot of copyrights and watermarks, and then we'll end with the panel. And we're very lucky to have Aaronson to start on some watermarking and start the whole trend of watermarking. And then take it away.
All right. Well, always great to be here. Thanks, Shafi, for inviting me. So I was asked to sort of kick off the morning session on watermarking by giving a very brief talk with this self-explanatory title of Watermarking Where To. And yeah, so I am of UT Austin, no longer of OpenAI, but I will, talk about stuff that I did while I was there. So I just have one slide to review the idea of watermarking LLM output, which I assume that most people here have encountered before. Okay, but the basic idea is why can't we add a hidden statistical signal to the outputs of an LLM, or other generative AI products, but I'll mostly focus on LLMs, in order to make it easier to later prove that, yes, this output came from not only an LLM, but this particular LLM. Okay, so why would we like to do that? Well, okay, so let me start by just, why should we expect this to be possible? The reason to expect it to be possible is that LLM outputs are already probabilistic, right? This neural net, this transformer is already repeatedly choosing the next token from a probability distribution. So there is entropy there. Okay, and wherever there is entropy, you might as well replace some of it by pseudo entropy that encodes a hidden message, if you want to. Okay, so so that's the basic idea. I mean, if someone asks an LLM to list the first 1,000 prime numbers, then maybe you can't watermark that. Okay, but most of what we use LLMs for, the same prompt could lead to many different generations, and so in your choice of among these exponentially many different generations, you could encode a signal. And why do we want to do this? Well, the most well-known use, maybe the best-known misuse of ChatGPT and other LLMs in the world right now is academic cheating. I'm sure no one here has been involved with such things, but one hears that a large fraction of all the homework, all the term papers in the world are being done using LLM assistants. So wouldn't it be great if teachers and professors had a tool for clamping down on that? Okay, there are also more serious misuses, election misinformation, propaganda, state-generated, social media campaigns, where it would be nice to know is an LLM behind this. Okay, and then there's also a less obvious application, which is it would be great to be able to identify LLM output on the internet, if only so we can exclude it from the future training data. So we're not sort of polluting our own pool of future training data. Okay, so I started advocating for this, almost as soon as I came to OpenAI, which was in the summer of 2022. This was, before ChatGPT was released, and it just seemed clear that, people are going to want to know what comes from an LLM or not. And, unlike, aligning an AI with human values, this seems like a problem that we might be able to formalize and, make some progress on, we understand what progress would look like. And so I proposed a scheme, in like fall of 2022, gave a bunch of talks about it. And then many, many other people sort of picked up the torch, some of them here from groups at Maryland, at Berkeley, at Stanford, Google DeepMind, and you're going to hear from some of them later today that have actually improved on my original proposal, have rediscovered things, and have done it better in many ways. Okay, but I'll just show you one slide about sort of what was my scheme, sort of how does it work? Because to some people, it came as a surprise that watermarking of text would even be possible at all. Or they thought, well, maybe it would be possible, but you would have to degrade the quality of the text. You would have to, and no, none of that is true, right? You can put in basically undetectable statistical signal into text, that encodes a watermark. And so it's worth seeing how such a thing is possible. So basically, our document is just like an array, right? A big array of positions, T, where at each position we can choose a token to go there. Okay, and what our LLM is doing is it's constantly generating a probability distribution over the next token, T. Okay, conditional on the previous tokens, say 1 up to T minus 1. Okay, so I'll call a choice for the next token, I. Okay, and I'll say, our LLM is outputting these probabilities, call them PTI, right? And normally, what happens when you run ChatGPT or Claude or Bard or whatever is that you're just repeatedly sampling from those conditional distributions. Okay, but you could do other things instead. And if you set temperature to 0, then you're saying always choose the highest probability next token. Okay, that's one way to make it deterministic. But another way to make it deterministic would be to choose pseudo-randomly the next token. Okay, and that's what we're going to do here. So let's say that we have some pseudo-random function, and based on the previous k tokens, so like the k-gram immediately preceding, we just pseudo-randomly output some number RTI, which I'll think of as a floating point from 0 up to 1. Okay, but which depends deterministically on those tokens. Okay, but looks like it's random. Okay, then here is a very simple scheme for watermarking. All you have to do is at each position T, choose that token I that maximizes RTI to the 1 over PTI power. Okay. So, one has to think about this a bit, but the key property is that if these RTIs were indistinguishable from really random real numbers in the unit interval, then this rule would dictate to choose each token I with probability exactly PTI. Okay? This is the key fact that you can prove, which means that if you can distinguish the output of this rule from normal output of the LLM, then in some sense you are breaking you are distinguishing the pseudo-random function from a truly random one. There are some caveats there, like if the same k-gram is repeated over and over, then you can notice the difference. Okay, but empirically, this leads to output with the exact same quality. And then, if someone later gives you a document and you want to know, did this come from the LLM or not, then there's a detection method, okay, which is basically you just take the document. You don't need to know the probabilities in the detection phase, right, which would require knowing the prompt, which you don't have. All you have is the document, but from the document you know all the k-grams, and from the k-grams you know all these numbers RTI, which means that you can compute a sum, of some function of those numbers. And then what one proves is that in a watermark document, that sum will be systematically larger than it is in a non-watermark document. Okay, so then it just becomes a statistics problem. Like, how much text do you need in order to get a strong enough signal? Okay, and So what are the basic properties of the scheme? So as I said, it does not affect the quality of the output. We confirm that in A/B tests and experiments. But if you really want cryptographic indistinguishability, like for someone to not even know that you are watermarking, if they're looking for it, that you have to work a little harder for that. But listen to the talks later today by Miranda and by Noah. They will talk about how to get cryptographic indistinguishability, which was more than I even hoped for. Okay, there is almost no computational overhead to running this scheme at inference time. It's easy to do. It doesn't take that much text to detect a watermark. So the basic asymptotics are that if alpha is the average Shannon entropy of like the next token, conditional on the previous tokens as perceived by the LLM itself. So, say alpha is like of order 1 in, normal LLM output, and you are willing to tolerate a probability epsilon of a false positive or a false negative, then the number of tokens that you need scales like 1 over alpha squared times the log of 1 over epsilon. Okay, so in practice, a few hundred tokens, you normally get a pretty good signal. A few thousand tokens, you can be, more than 99.9% confident, right? And the thing about, watermarking is, okay, we can tolerate false negatives, but like if we're going to be accusing a student of cheating based on the output of our tool, then we really, really don't want false positives, right? We want the rate of those close to 0. Now, this scheme also has robustness against local modifications. Okay, so if someone changes some words or they reorder some sentences or paragraphs, as long as they've maintained a large fraction of the k-grams, there's still going to be a signal that we can pick up because it's a sum over the k-grams. On the other hand, what we don't have is robustness to global modifications. So if someone were to ask GPT to write their term paper in French and then put it into Google Translate, that would destroy the signal, okay? In fact, there's even much simpler things that people have pointed out that would destroy the signal. This is what we call the pineapple attack, where you ask GPT, let's say, write my term paper on feminism in Shakespeare, but insert the word pineapple between each word and the next. Okay, and it could follow that instruction, maybe with a slight degradation of quality, and then you take out all the pineapples, and now you have a document with a totally different sequence of k-grams than the one that was watermarked, right? And so, you could worry about all the possible attacks of this kind. And in fact, Boaz Barak and his students and others a year ago had what they called an impossibility theorem for watermarking, okay? But what it basically says is that if you can take a random walk on the set of all documents by like repeatedly finding a phrase and replacing it by another phrase that is just as good, if you can take that random walk and you can do it in a way where that random walk will preserve the quality of the document and the walk will be rapidly mixing over the set of all documents that are equally good for you, well then, that would remove any watermark, right? So, they sort of baked into the assumptions, the conclusion that they want. But, it's true that is a class of attack that one ought to worry about. One can wonder, is that really true? Is modifying a document really a rapidly mixing random walk? Those are very interesting questions. But now to come to the key question, why has OpenAI not deployed this yet? An obvious answer would be competitive risk, right? Surveys showed that some fraction of users just don't like the idea of watermarking. Those might be, those might even be licit users. I don't know which, how they're using it, but some customers, if everything is watermarked, they might switch to a competing LLM that doesn't watermark. Okay, and so that underscores, that there's, just like many other things in AI safety, that like you want a coordinated solution, right? It's very hard for one company to do it unilaterally. But then a question that kept coming up was who gets access to the detection tool. Okay, so OpenAI did not want to give everyone access because, for example, then the attacker would also get access, and they could keep modifying a document until it no longer triggers the detection. So, so they kept, wanting to say, well, maybe we can restrict access to academic grading websites or professors journalists studying misinformation. Okay, but then you have to create a whole infrastructure for gatekeeping access to the detection tool, and that was sort of never done. There was, not sort of an engineering team to do that. Of course, it was constantly pointed out that, all the watermarking methods that we know can be circumvented with some effort. The main hope is that, for example, most academic cheaters will not be going to great effort. If they were effortful people, then they wouldn't be cheating, right? But okay, another argument that kept coming up was, well, shouldn't there, aren't there some users who should be able to use an LLM without disclosing it? What about English as a second language speakers, right, who use GPT to improve the fluency of their writing? Is it unfair to them that everything they write will be watermarked? So it's true, there are trade-offs. Like, I don't know how to design a watermark that only works on unsympathetic cases. And then, I just have limited political skills. I am a complexity theorist, who was doing this part-time. And I think it takes a different skill set to actually, push something into a product. But there was a major story in the Wall Street Journal just this summer that was called, there's a tool to catch students cheating with ChatGPT. OpenAI hasn't released it, and they talked to a bunch of OpenAI executives off the record to explain, everything that I told you in the last slide. Some of it was even new to me. So, I'd recommend this article if you want to know more. I should mention that Google actually has rolled out some form of watermarking, which they call Synth ID. Okay, a lot of it just this past summer. But they haven't made the detection tool publicly available. So you have to apply for access to the tool. Sam here tells me that he tried and was denied access. So I'm not sure what their eventual plans are, but they do seem to have gone further on it than OpenAI or Anthropic have. So now to conclude, where to? So it would be great if we could have coordination among at least OpenAI, Anthropic, DeepMind to decide what to do about this, and avoid this tragedy of the commons problem. If people agree about this, there's been talk about, organizing a public letter of academics about it. That could be interesting. And then there are now legislative mandates for watermarking. Actually, just a month ago, a bill was passed here in California. This one was signed by Governor Newsom, unlike 1047, which he vetoed. Okay, but he signed SB 942, which starting in 2026 will mandate watermarking for audiovisual content, although not text. Text was taken out. Okay, somehow at the political level, people are obsessed with deep faked videos and stuff, and maybe they don't care about text because no one reads anymore. I don't know. But the EU might also mandate watermarking. So there could be a legislative route here. And then on the research level, can we watermark at the semantic level? Can we clarify what class of attacks can and can't be defended against, like in light of the Barak et al. Theorem? So thanks. Yeah.
Sure.
If there are any questions?
Yeah.
How do you think watermarking would be enforced if it was public, if it was made mandatory by legislation? How would it be enforced? Would it be best effort? Would it be?
That's an excellent question, right? Because if one is going to mandate watermarking, then what kind of watermarking does one mandate? And so people have, in the existing bills, people have had clauses like you have to use, the best currently existing technology. But what on earth does that mean? Right. So I think there's a real question there, right?
Otherwise, people could enforce a very weak signal that wouldn't change anything. And
Exactly. So that's where kind of the research question intersects with the political question.
What is Google using for that?
They are using something similar to what I talked about, right? It's like something similar to my scheme, I think. Yeah.
How hard or easy would it be for someone to create an automated tool knowing your algorithm would, change the outputs so your confidence in your prediction drops enough that you don't accuse cheaters?
Well, I mean, if you can change the query being made to GPT, then it's very easy to evade this. If you only have the output, then again you can evade it, but then you have to work hard or do something like in the Boaz Barak paper, like paraphrasing, rephrasing. All right.
Okay.
Yep.
Miranda Christ is going to give us a talk on similar than aircraft. Take it away, Miranda.
Okay, can everyone hear me? So I will be talking about pseudorandom error correcting codes with applications to watermarking generative AI. This is joint work with Sam Gunn, who's a student here at UC Berkeley, and he's also here wearing the inverse of that sweatshirt, so you can find him.